of u, and this u is again function of x, and then the composite function forms, that is y is equal to f of g of x. Okay, so we can find its so while differentiating this composite function, that is y with respect to x, we will first of all differentiate f. So we will get f dash, and the interior part of that g of x will remain as it is. Again, in multiplication you will take derivative of g, that will become g dash. This is also called as chain rule. If y is a function of u, u is a function of another let me repeat it. If y is a function of v, v is a function of u, okay, and again this u is a function of x. So three functions are getting involved in this: u, v, and x. Okay, so in this case, while differentiating y, we will get y with respect to x by using chain rule, that is a dy by dx is equal to dy by first of all u, then again u is function of v is a function of u, that's why dv by du, and u is a function of x. So let me repeat. See here, y is function of u. So we first of all, for dy by dx we will get dy by dv, because initially it is given that y is function of v. So dy by dv, see here, into this v is a function of u, so we will get dv by du, and this u is a function of x, so we will get du by dx. This second point. Now for third point, for n functions involved in composite function, here only two functions are involved, f and g. Here are three functions involved, f, g, and h. What will happen if there are n functions involved in the scenario? In such case, don't get scared, my friends. For us to help, there is a chain rule, that is universal rule, that will help us. See, y is a differentiable function of u1, u1 is a function of u2, u2 is a function of u3, u3 is function of u4, u4 is function of u5, u6, 7, 8, and it goes continue till n. In such case, what will happen? This dy by dx is equal to, first of all, y is given in u1, so you will write dy by du1, du1 upon du2, du2 upon du3. In this way you will get, and last term you will get dun upon dx. So this will be the last term of this. So these are the three notes, my friends, you people have to keep in consideration. All of these are called as chain rules. Okay, so friends, we will see one problem of this theorem, regarding this theorem. So practice problem exercise 1.1. So what is given here? Let y is equal to, first of all, do the labeling, means label the problem. What do you mean by labeling? That also I will explain you. Means you need to label this problem with one variable, that is nothing but y. In the differentiation we will label only by y most of the time. In integration we will label by I. So what you need to do, let's consider what to do. Let's consider u is equal to five. So y will turn, this is equation number 1, this is equation number 2. So y will turn, this is now u raised to 5 by 2. Okay, now y has been given in u, so differentiate y with respect to u. that is dy by du. The derivative of both these sides we will take with respect to u. As we know, as derivative of x raised to n with respect to is n x raised to n minus 1, and again derivative of x, that is 1. So with the same logic, dy by du will be 5 by 2, u will remain as it is. Here was n, so n minus 1, so 5 by 2, so 5 by 2 minus 1, so that will turn into u. 5 by 2 minus 1, 2 will go, so that will be 3 by 2. So what you have got? You have got dy by du is equal to 5 by 2 u raised to 3 by 2. Okay, so this will be equation number 1. Now what is u? We have here u. See, this is u. What is u? U is equal to 2 x raised to 3 by 2 minus 3 x raised to 4 by 5 minus 5. So u has come in x. So we will differentiate u with respect to x. So what we will get? Du by dx, derivative of both the sides with respect to x. Okay, so derivative of this term, 2 is a constant, so we will take derivative of x raised to 3 by 2. So derivative of x raised to 3 by 2, with this logic, 3 by 2 will come front, x as it is, power minus 1, n minus 1, so power 3 by 2 minus 1, 3 by 2 minus 1. Okay, minus this 3 will turn as it is, x raised to 4, see, this 4 by 5 will come front. Okay, x raised to 4 by 5 minus 1. Okay, minus derivative of 5. So therefore this du by dx is what? See, 2 into 2 will get cancelled, so 3 x raised to 3 by 2 minus 1 by 2, minus 3 into 4 12 by 5, x raised to, this 5 will go up, so 5 minus 4, that is 1, so minus 1 by 5. Okay, 5 is a constant, so its derivative is 0. So 3 x raised to 1 by 2, so that is root x, minus 12 x raised to minus 1 by 5, so it will become 1 upon x raised to root 5, isn't it? So ultimately it will be du by dx is equal to 3 root x minus 12 upon 5, okay, to minus 5th root of x. So see friends, as I have told you, du by dx, what will be du by dx? 3, this 1 by 2 is root x, minus 12 by 5, this is a minus sign, so it will come in denominator, and 1 upon 5, so it becomes the 5th root of x, isn't it? So in next step, 5th root of x. According to the chain rule, dy by dx is nothing but the du by dx into dy by du into du by dx. From equation number 1, we know dy by du. So in equation number 1, this is the dy by du. And just now, in equation number 2, we have find out du by dx. So this is du by dx I have replaced from equation number 1 and 2. But still this u is the dummy variable. This we have taken. This is not given in the problem. So we will replace this u. So its value is given as u. What was u? U was 2x raised to 3 by 2 minus 3x raised to 4 by 5 minus 5. I have altered. In book here is 4 by 3, but purposefully I have taken 4 by 5 so that you can deal with the concept of x raised to minus. If the exponent power of x comes minus, then what happens? So we will replace this u by this terms. So our dy by dx will become this is u. This is u, but u raised to 3 by 2 into this part also we need to consider minus 12 upon 5 fifth root of x. This is the final answer of the given problem. Very simple. Okay, y was given as 2x raised to 3 by 2 minus 3x raised to 4 by 2 4 by 5 minus 5 raised to 3 by 2. We consider this as u and we turn it into the chain rule. Okay, so for today we will stop here, and once again, if you liked it, then like the video, share it so that the needy students can go through them. Okay, so we will stop here. Like and share. Don't forget this. Thanks a lot.